Namaskaram friends. So in this video, I am going to talk about geomagnetic storm. In our previous lecture, in one of our previous lecture called coronal holes, in that topic there is a terminology of geomagnetic storm. Here we are going to talk about a bit of in detail about geomagnetic storm. So it is related with solar flares, which sun emit into the space, and it also impact the atmosphere around our planet Earth. And also there is a due to which there is a disturbance in you can say radio as well as uh, other other communication which are occurring in that region in ionosphere. So what geomagnetic storms are, what are is important, and where and why it is very significant, and in which region its impact we see clearly. Okay, like in poles, like aurora boreals, these are due to magnetic field and solar flares. Magnetic field and solar flares combined, they produces a very beautiful scenery of aurora boreals in the poles, in northern pole as well as in southern pole. So in this video, we are going to talk about very briefly about geomagnetic storms. Okay. So what geomagnetic storms are? You can clearly just a minute. Geomagnetic storm. See here, geomagnetic storm. Okay. So according to U.S. government agency, an agency of U.S. government called National Oceanic, related to this ocean and atmospheric, that means dealing with atmosphere as well as ocean. So U.S. government agency called National Oceanic and Atmospheric Administration. According to that agency, geomagnetic storms relate to Earth magnetosphere. Earth magnetosphere, that means uh, outside the atmosphere of Earth, the present surrounding is called Earth magnetosphere. The space around the planet that is influenced by its magnetic fields, and that space which is beyond our atmosphere is impacted by, influenced by magnetic field. That area is called Earth's magnetosphere, and geomagnetic storms are related with that region. So if question asks about in which region we see geomagnetic types of phenomena, so in Earth magnetosphere, a region beyond Earth atmosphere which is influenced by magnetic field. Okay. Next one is when a high-speed solar stream, remember high speed, when a high-speed solar streams arrive at the Earth in certain circumstances, not all, okay? When high-speed solar stream arrive at the planet Earth in a certain circumstances, it can allow energetic solar winds particles to hit the atmosphere over the poles. Okay, not all scenario. In certain circumstances, when high-speed solar winds hit the atmosphere over the poles, when energetic solar wind particle hit the atmosphere over the poles. So what the important point in this is, remember high speed solar wind stream arrive at the Earth. Not all situation is circum situation. It can allow this high speed solar stream allow energetic solar wind particle to hit the atmosphere over the poles. Here you can see the phenomenon of aurora boreals. Okay. Such geomagnetic storms cause major disturbance of the magnetosphere because its speed is very high and hit the atmosphere of the poles, so it disturbs the magnetosphere of planet Earth, as there is a very efficient exchange of energy from the solar wind into the space environment surrounding Earth. So there is a very efficient exchange of energy from solar wind into the space environment surrounding Earth called magnetosphere. Okay, so here efficient amount of energy is exchanged. That's why it causes disturbance to the magnetosphere, geomagnetic storm. In case of strong solar wind of very type, but in case of strong solar wind reaching the Earth, the resulting geomagnetic storm. When a strong solar wind reaching the Earth, so the resulting geomagnetic storm can cause changes in ionosphere, part of the Earth upper atmosphere. Again, in this picture, you can clearly see this is the atmosphere of planet Earth: troposphere, stratosphere, mesosphere, thermosphere, exosphere. And this portion, thermosphere plus exosphere, is called ionosphere. So when high magnetic field hit the, and this outer space is called magnetosphere. So when high solar wind hit the environment surrounding planet Earth, so it disturbs the ionosphere also. Okay, and there is changes occur in the ionosphere. And this ionosphere is a part of Earth upper atmosphere. You can clearly see 5 parts of atmosphere: tropo, strato, meso, thermo, exo. So the outer part of atmosphere is called ionosphere, combining exosphere plus thermosphere. And when strong solar wind hit the magnetosphere, changes also occur in the ionosphere, because below the magnetosphere is ionosphere occurs. So if it is strong, if it is not that strong, it impacts only magnetosphere. But if solar winds are strong, so it changes occur also in ionosphere. Radio and GPS signals. Radio and GPS signals travel through this layer of the atmosphere. You know that radio signals and GPS signals are travel through ionosphere. So if high solar winds impact the ionosphere, so these signals are also get disturbed. So communication is get disrupted. Because radio and GPS signals travel through this layer of atmosphere called ionosphere, so the communication can disrupted because this region is disrupted. So I hope you understand the whole idea of geomagnetic storm. It is emitted from the sun with solar flares, and when these solar flares are strong, they hit the magnetosphere of planet Earth, and if it is very strong, it also changes the ionosphere. And in ionosphere, we know that GPS and radio signals are propagating, so communication disturbance is also occur if strong solar winds impacted or create changes in the ionosphere. And also remember some points. In geomagnetic storms are very strong, so there is efficient exchange of energy between magnetosphere and solar winds. Okay, and this definition of geomagnetic storm related to Earth magnetosphere is given by the National Oceanic and Atmospheric Administration of US government agency. Okay, so these are important points. In this picture, you can clearly see solar flares. Here, Earth's magnetic field. So when solar flares is strong, it also impacted the magnetic field of Earth called magnetosphere. And if it is very strong, it also impacts the ionosphere. So this is the atmosphere of Earth. Okay, so it impacted magnetosphere. It is associated, geomagnetic storm is associated with magnetosphere, and if it is strong, it affects the ionosphere and disturb the GPS and radio signal. So clearly see planet Earth, sun, these are solar flares. Okay, if these are strong, it reaches here. Okay, it also impacted this region called outer space or magnetosphere. If it is very strong, it impacted ionosphere also. So this picture gives you a clue of sun, its solar flares, earth, its atmosphere, and the efficient exchange of energy between solar winds and magnetosphere. So now we are going to solve one question based on it. What we have read till now, now we are going to solve one question based on it. Okay. So consider the following statement regarding geomagnetic storm. First one is, during geomagnetic storm, there is a very efficient exchange of energy from the solar wind into the space environment surrounding Earth. In this picture, you can clearly see efficient exchange of energy between solar winds as well as magnetosphere. So this one is correct. Second one is, geomagnetic storm causes a major disturbance to the Earth's magnetosphere. Yes, of course, this is also correct. Third one is, geomagnetic storm can disturb radio and GPS signals that travel through the ionosphere. Yes, this one is also correct. That means statement 1, statement 2, statement 3, all the statements are correct. That means option D is correct. Just check we are on the right path or not. Option D is correct. That means we are on the right path. So I hope you love this video, you enjoy this video, and gain some perspective, some knowledge out of it about geomagnetic storm, about ionosphere, about magnetosphere, about layers of atmosphere, and impact on radio and GPS signals. So I hope you love it, enjoy it, and gain some perspective out of it. So, namaskaram. Thank you.